In this video, we're going to apply a /25 subnet mask into an IP address and identify what happens to the network. Specifically, how many addresses are going to be in the network when we expand the networking portion of the subnet mask by one more one. So, /25, what does that mean? Once again, the number of consecutive ones in a row in the subnet mask will determine the slash value. And in this case, we've got 24, and then we've used one digit in the fourth octet, and that is now considered a 1 also. So the highest order bit in the fourth octet is going to be part of the network and no longer part of the host. So what does that do to the size of our networks? It makes it very simple. There are now only 7 digits here. There are only 7 digits here that we can make addresses out of. So that really creates, you don't really want to say 2 networks, but where there was one network where we had a consistent series of zeros and ones, where we had 8 zeros, 1, 2, 3, 4, 7, 8 zeros, and then we had 8 ones, 1, 2, 3, 4, 5, 6, 7, 8 ones. That equaled 0 through essentially 255 with the /24. That was the /24. And now that we're at /25, we've got a little bit of a different story here. We've got 7 digits left that we can make zeros and ones out of. So we've got 1, 2, 3, 4, 5, 6, 7 zeros, or 1, 2, 3, 4, 5, 6, 7 ones. And what is that going to give us for a particular network size? Now, that's going to be 0, and then 7 ones in a row is going to be, and you're going to have to just trust me on this one, is going to be 127. It's going to be 127. So the network sizes that we can now make are not 256 addresses big, but they are 128 addresses big, or half the size of what they were previously, just by removing one of the digits from the fourth octet and making it network as opposed to making it host. So we're cutting the network size down by half as we move the network into more space in that fourth octet. Okay? Hopefully that makes sense. Now, this actually takes that space that we had previously and turns it into 2 separate networks. There's a network where this position is a 0, as it is with this 10. And then there's another network that would be created where this position, the 25th position, would be a 1. So it effectively makes what was one network, 0 to 255, it effectively makes 2 networks, 0 to 127. And that's with a 0 in this position. That's with a 0 in the 8th position. Right. And then if we made that a 1 in that position, that would give us 1, 2, 3, 4, 5, 6, 7. That would equal 128. And the highest number, 1, 2, 3, 4, 5, 6, 7, 8, would equal 255. So it essentially makes 2 networks, one that has a network ID of 0 and a broadcast ID of 127 in the fourth octet, and another that has a network ID of 128 through 255. So our network ID and our broadcast ID for these particular systems would be, network IDs would be 0 and 128, and the broadcast ID would be either 127 or 255, depending on if the number was between 0 and 127 or if it was between 128 and 255. In this particular case, our number is 10. And 10 has a 0 in this position, so the network ID for this address is going to be 192.168.100.0. The broadcast address would be 192.168.100.127, and anything in between there would be in that same network.